Hello and welcome to my channel. I'm excited because I just received in the post this filter, 868MHz cavity filter. Not sure how many resonant cavities there are, several. And I didn't want to use surface acoustic wave filters because of the high insertion loss, and they won't handle a lot of power. I think this is rated to handle up to 20 watts of power, which of course we don't need at 868MHz. Would not even be legal in Europe anyway. I think the maximum, well, anyway, let's not go into that. So this is for use with Meshtastic or Reticulum Meshchat, and I was having problems with antenna noise pickup outside the band that was affecting the receiver. So I thought put a filter in front of it so that only 868MHz band is passed from the antenna to the receiver. And of course the first thing to do is to test this filter, which is what I'm doing here. I've got it plugged into, sorry about the wobbly handheld webcam. Plugged into my Nano VNA, and this is 860MHz up to 880MHz. So it's a 20MHz span. I'm trying to arrange this so we can see better. Sorry about that. The ceiling is white and it's a sunny day, and I should be doing this in the dark, of course. But don't complain about sunshine. Anyway, that's centered, well, the marker is at 869.4, which is close to the Meshtastic frequency or reticulum frequency of 869.525 is close enough. And you can see we've got an insertion loss being measured here. This is the 0 dB line, I hope. Where does it say that? Okay, the scales have changed yet again. Anyway, this is the 0 dB line, and of course this has been calibrated just a few minutes ago, this VNA, which is something you always have to do, is calibrate it before making measurements. And we've got an insertion loss of about 1.2 dBs, it says. If I go down in frequency, you'll see that it does get a little bit less, maybe 1.06 maybe dB. So there's a teeny bit of ripple, but not very much. Quite often you get 1 dB of ripple on a filter, and this is much lower ripple, so it's a nice filter. And to be honest, the center frequency is a bit lower than what I would really like to have. Maybe I'll try adjusting it myself, but first I want to test it, because this is good enough already to have what is that, just over 1 dB, just less than 1, say 1.2 dBs insertion loss is okay for testing whether the interfering signal problem from out-of-band signals goes away. So that is the filter response, and what I'm going to do next is connect it in line between a node, an R node, which is in this box. This is actually a Raspberry Pi 0 and a rack radio node. And it currently has a dummy load connected. It's a 20 dB attenuator, which then gives 40 dB return loss from reflection at the end, which is a good match. And I'll show you soon that using this you can actually see how much noise is generated in the receiver itself to measure the noise floor. Anyway, that is going to be the transmitter powered by a power bank. And I'm going to put it through the filter, well, first without the filter, measure the received power, which I'm going to do on this spectrum analyzer, tiny SA spectrum analyzer, with of course a big attenuator in front, because we don't want to overload the input. Maximum input power here maybe 0 dBm or even less, can't remember, but with a 40 dB attenuator it's going to be well enough protected. This thing will handle up to 15 watts, and the R node puts out 100 milliwatts if you're lucky, so everything's in the safe region. So I'm going to use this as a power output measurement. Not the best kind of power meter, but it's better than nothing. So I'm just going to pause the video while I connect that up. Here is the setup to measure the output power. So I've got the filter, which I'm measuring the power coming through, and I've got an attenuator to protect this tiny SA Ultra spectrum analyzer, and the transmitter is the rack module inside here, and the output goes to the filter. This is powered by a power bank. And then to make the transmission happen, I'm going to use the software Meshchat, and I'm going to press on the Announce Now button when I want to transmit. The only problem is that transmission will just be a few hundred milliseconds long. In fact, you can see some on here. There's one of them. That's an announce from a node outside, and this is a response from this little node I just showed you. It's a weaker signal. The other signals you can see here are other Meshtastic probably signals in the neighborhood. So before doing this, I need to do a couple of things. I've got a 40 dB attenuator here, so I need to tell the analyzer there's 40 dBs so that the readout is accurate. I'm just waiting for it to focus. So how do we do that? Level, external gain, and I'm going to say that's minus 40 dBs. So there's an external gain of minus 40 dBs. That's taking into account the attenuator now. Oh, there's a transmission just happened. But of course you can't really read the power level because it's so short. So what I'm going to do is also turn on max hold. So we go back. Sorry about the wobbly camera. I really should do screen captures on this analyzer, but I'm too lazy to connect it to a computer. Trace, and then you have to choose calc, which is currently off, and I'm going to say max hold. So now it's going to max hold any readings so that you can actually measure them. The center frequency is about 869 megahertz, and the span is 800 megahertz. So what I'm going to do now is I'm going to press the button on the other laptop to transmit a signal. I'll do it probably several times. And there's one already, which has been held. Let's do another one, let it build up a little bit. And another one, so it was 3 bursts. And the marker has jumped to the peak because it's on peak searching. And if we look at the power level, it's 18.4 dBm at 869 point. It's actually 425, but it's saying a slightly higher frequency because of the calibration of the frequency of the analyzer. It's not the most expensive spectrum analyzer in the world. So it's saying 18.4 dBm, and the node is set to transmit plus 22 dBm, but I don't think they ever managed that. Maybe you get 20 dBm out of it, and remember there's a 1 dB loss in the filter, which will give 19 dBm, and then 18.4 is half a dB less than that, which could be accounted for perhaps with the cables, the extra cables that I put in here, the extra connectors, the accuracy of the whole test setup. There's nothing too special, but you can see anyway that the filter's causing about a 1 dB loss at 869 megahertz, which is what I measured earlier with the network analyzer, was showing 1.2 dBs insertion loss. So it seems to be behaving itself. And of course the next thing to do is to go outside and plug in an antenna and see if the filter is solving the interference problem. And I think that'll come in the next video. So that's all for now. Remember to ask questions, make comments, and I'll see you in another one.